In this section of probability, we are learning to draw a tree diagram for experiment that consists of 2 or more stages. Typically, it's only 2 stages or sometimes 3 stages. So it can be something like you take 2 items, or it's something like you do step 1, then followed by step 2. So it's usually for experiment that involve 2 stages. Okay, so I'll be showing you 3 examples. Okay, so the first 2 examples look almost identical, except that it's the idea of with replacement or without replacement. Okay, so I'm going to show a very simple one. Of course, you got to logic out to different contexts. So the very simple logic will be there is a bag containing 3 red and 5 yellow marbles. 3 red and 5 yellow marbles. And I'm going to draw from this bag 2 marbles with replacement. So when we say we draw 2 marbles with replacement, that means, right, you take one, then you return, then you take the second one. So in example 8, I will be showing you the one without replacement. Okay, so there's a difference, but there's also some similarity. Okay, so I'm going to be drawing the tree diagram to show the process of picking up 2 marbles. So you might want to think of it like this first. So this is your initial bag. So when you put your hand inside the bag, what could be your first marble? So when you put your hand inside the bag, what could be the first marble? So the first marble could be a red one, or the first marble could be a yellow one. So of course, it comes with a certain probability. So in this case, our total number of marble is 8. So I will have a 3/8 chance that my first marble is a red one. Or I can have a 5/8 chance where the marble is the yellow one. So that will be my first marble. Okay, after you pick the first marble, so for example, if you pick the first marble is red, you're going to return. So upon returning, your bag, it is still having 3 red and 5 yellow. You take the red one, you return. Okay, when you return, right, this is how your bag look like. So from where it is, you're going to take the second ball. You're going to take a second marble. Again, it could be a red or it can be a yellow. And because that's how your bag look like, your bag still got 8 marble. So the probability will be 3/8, 5/8. Okay, but what happened if let's say you take the yellow color and then you return the yellow color, your bag will still look like this because you return it. So if let's say in a scenario where the first marble is a yellow, you return that yellow, you continue to pick the second marble, you are still going to get red, you are still going to get yellow. The probability will still be 3/8. The probability will be 5/8. So from here, right, I can have the possible outcome. So what will be the outcome of picking 2 marbles? So the outcome will be like this. It can be red and red. So it's red and red. So red and red, what is the probability? So remember in one of the previous example I mentioned, if the keyword is the and, the probability will be a multiplication. So it will be a 3/8 times 3/8. Or the outcome can be a red followed by a yellow. So it could be a red followed by a yellow, and the probability will be a red multiplied by a yellow probability. Okay, or it could have been yellow with a red. So it could be a yellow and red. And the probability will be yellow probability and a red probability. Okay, lastly, it could have been a yellow with an yellow. And the probability will be the yellow probability, 5/8 times 5/8. Okay, so if your probability 3 is correct, when you add up the 4 numbers, when you add up the probability for the 4 cases, it will actually add you into a 1. There are 4 possible outcomes, and all the probability will add up to 1. So that's the characteristic of probability 3. Okay, so with all the possibility, all the possible outcome, a bit like sample space, and all the relevant probability, we can answer the question. From here, it's actually very easy to answer the question where probability where both marble are yellow. So if I would like the probability that both marble are yellow, so that will be the last part here. So probability that both are yellow, that will just be the last possible outcome. 5/8 times 5/8. Okay, then the next probability. The next probability, both are different colors. So you look at the outcome. Okay, which are the outcome where you got different colors? So there are 2 situations where you can have 2 different colors. So you got to add up the 2 different situations. So probability of 2 different colors. It will be probability of red and white, or probability of white, yellow and red. So essentially, I'm adding up these 2. So these are the 2 possible situations where you got 2 different colors. So if you add them up, you got 30/64, and then you reduce the probability. So in a way, after you draw your tree diagram, you get the outcome, all the possible outcome, which a bit behave like sample space. Okay, so a third marble is drawn. Calculate the probability that all the 3 marbles are red. Okay, so if you need to pick a third marble, so essentially you got to branch out one more time. So essentially you got to branch out one more time, but you can choose not to branch out. Okay, you look at the situation. Where is the situation where all the 3 are red? So these 2 are already red. So you need the third one to be red. So imagine you take the second red ball, you are still going to return, and your bag is still going to consist of 3 red and 5 yellow. So if you pick the third one, what is the probability that you will be a red? It will still be 3/8. So without extending my probability tree, I can find the probability that all the 3 marbles are red. That will be 3/8 times 3/8 times 3/8. So you can punch calculator from there. So you will get 27/512. So it doesn't mean that if you draw the third item, you actually need to branch out one more time. It will be quite messy, but you can use your current tree diagram to help you. So that is a typical tree question with replacement. Replacement means you take one, look at it, return, and then you take a second one. So we're going to repeat the whole thing all over again for the next example, but this time around, it will be done without replacement. So the meaning of without replacement means you take one, you do not return. Do not return, then you take a second one. So the effect will be, right, it actually reduce the total number. Okay, so now I'm going to draw the situation, the same quantity. So this is a bag. So if I take my first marble, it could either be a red or a yellow. The probability will be 3/8 and 5/8. Okay, now I'm going to take the red one and I'm not going to return the red one. So if I'm going to take the red one and I'm not returning the red one, my bag will be left with 2 red and 5 yellow. So I'm not going to return my red one. I'm not going to return, and I'm going to continue to take my second marble. My second marble can still be a red or still can be a yellow. But the probability will be different because you are not returning the first red ball. So here you'll be 2/7. Here will be 5/7. Okay. So in the next situation, I'm not returning the yellow ball. So I get a yellow ball and I'm not returning this yellow ball. So I'm left with 3 red and 4 yellow. So my total will be 7. So from here, I'm going to pick my second marble. So look at what is left in your bag. You got 3 red that are left in your bag. So there will be 3/7. Yellow will be 4/7. Then the same thing happened. We're going to explore the outcome. So the outcome will be red and red with the probability of 3/8 times 2/7. Or it can be red and yellow. And the probability will be 3/8 times 5/7. Okay, or it can be yellow followed by a red. The probability will be 5/8 times 3/7. The last possible outcome, of course, when both are yellow. So when both are yellow, it will be 5/8 times 4/7. So in the previous example, when we add up all these answers, we get a numerical 1. So right now, if you try adding up, you are still going to get a total probability of 1. So that this characteristic of a tree diagram will always hold. The total probability has to be 1. So from here, I can answer the question, what is the probability that both are red, both are yellow? So this will be the answer for B part 1. Okay, and what will be the probability that both are different colors? So if you add up this, that will be the probability of B part 2. So that's it. So in this question, I never asked about having the third marble. So we could have okay, so for example, if let's say we really have a third marble, so I'm going to draw a third marble. What is the chance that all the 3 marbles are red? All the 3 marbles are red. You can refer to the tree diagram. You already gotten the 2 red. So you might want to explore what is left in your bag. If let's say you're not returning the second red. If you're not returning the second red, you are actually left with 1 red and 5 yellow. So subsequently, if I draw out a red, it will be 1/6. So the probability will be 3/8 times 2/7 times 1/6. So you do not need to extend out the whole tree diagram. You extend out the relevant one to answer accordingly. So that will be the thing with and without replacement. So sometimes the context can be a bit more different. So you got to relate, okay, what are the items left in the bag after you do certain thing. Okay, so this one will be the idea with and without replacement.